Alright, for this lesson we're going to be talking about vertex form of a quadratic, and we're going to be talking about the transformations that we actually see when it comes to vertex form. So vertex form is in the format where it's a parentheses x minus h squared plus k. So technically, if I have, let's say, y equals 2 times x minus 3 squared plus 1, okay, I could multiply that out and I can put it back into that format that we're used to, which is the standard form, which is ax squared plus bx plus c. So this is the same, it's going to give me the same equivalent parabola, it's just in a different format. So when I look at this, technically this squared part right here, that squared part is representing that there's two parentheses. So when I have those two parentheses, that means that I'm going to multiply it out twice using my box method or the multiple distributive property, however you want to represent that. But I'm going to multiply these two out. So remember, when we do the box method, you set up your rows and columns. So we're going to have an x and a -3, and that is a -3 because there's a subtraction in front, and another x and a -3. I'm going to have x times x is going to give me x squared. Then I have -3 times x is -3x. -3 times x is another -3x. And then -3 and -3 is 9. So when I combine those like terms, that gives me x squared minus 6x, because -3x and -3x added together, that's going to give me -6x, and then plus 9 plus 1. So I distribute that 2, so that 2 is going to go to everything inside the parentheses. It's not going to go to the 1 outside the parentheses, but we're going to do it to everything in the parentheses. So that's going to be -2x squared minus 12x, and we're going to do plus 18 plus 1. So essentially, once everything is combined together, I have y equals 2x squared minus 12x plus 19. So what I'm trying to show you is that this vertex form that we're talking about, once it's multiplied out or expanded out, it gives me that standard form that we're used to. So what we're going to discuss today is what are some of the key features that we can identify in vertex form, because the vertex form can tell us, obviously, a lot of things. So the first thing that I want you to recognize, forget about the a in front first. So when I'm looking at the x minus, and then there's a number here, we call that h, and then squared, okay, plus k. The h and the k are what are going to represent your vertex. So the h and the k are going to represent your vertex. Now, in this standard form, what I need you to recognize is that this minus sign right here is going to cause everything to look opposite. So let's say that I have a vertex that has an x value of -2, and that's squared. Well, if I simplify that, that's going to become x plus 2, because a minus and negative gives me a positive. So whenever we're looking at the h is always the opposite value. So if I have, let's say, x minus 2, that means that my vertex starts with a positive 2 for the h. If I have x plus 3, that means that my vertex is going to have a opposite value of -3 for the x value. So it's called vertex form because it's what the h and the k are going to be the x and the y of the vertex. Okay. Now, we're going to come back to that, but we're also going to talk about some transformations. So we have a basic quadratic function, that what we call a parent function, that has that basic U shape, okay? And there's a lot of things we can do. We can shift it, we can move it over to the left or to the right, we can move it up, we can move it down. We can actually make it look skinnier, or we can make it look fatter, okay? So we're going to transform it. So we're going to start by looking at the a value. So these little symbols right here mean absolute value. So absolute value means that if it's a positive number, it stays positive. If it's a negative number, it's going to turn into a positive. So when we look at the a, we always look at the positive version to determine this. So if I have an A value that is greater than 1, we call that a vertical stretch. Now, it's going to vertically stretch by the A. So that means if it's going to vertically stretch, the Y values are going to stretch. So if the Y values are going to stretch, that means that, kind of think about it like slime. If you think about it like slime and I stretch the slime out vertically, then it's going to look narrower. So a vertical stretch actually looks narrower. If I have an A value, and the absolute value means the positive version, and it falls between 1 and 0. So why are we saying 0? Because if it's positive, it can't go below 0. That's going to be a vertical compression. Now, a vertical compression actually is going to look wider. So think about if you are pressing something in between your hands, like Play-Doh. If you take the Play-Doh and you press it between your hands vertically, you're pressing down, right? That means the Play-Doh is going to get wider. So if I have a vertical stretch, it's going to look narrower. If I have a vertical compression, it's going to look wider. Then finally, what happens if the A value is negative? Well, if the A value is negative, that means it's going to do a reflection, and it's going to be a reflection over the x-axis. So these are rules that you have to know. So you need to make sure you memorize these. So A value greater than 1 is a vertical stretch. If the absolute value of the A is between 0 and 1, that's a vertical compression. And then if the A value is negative, that means it's a reflection over the x-axis. Now, back to the vertex. So remember, the vertex is the point that is in the middle of the curve, okay? So the vertex is a point, which means it's got to have an x and it has to have a y. So the h and the k, the h represents the x value of the vertex, the k represents the y value. So when we're looking at the h, that is a horizontal shift. So horizontal means left to right, okay? So we're going to shift that graph, or we're going to slide it over. And remember, I told you that because of this negative right here, these are opposites. So if I have one of these and I have a plus h, that actually means we're going to the left. So it's the opposite of what you think it is, because originally it would have had a minus there. If I have a minus h, that means we're going to the right. All right, and then if I have a k, so the k is just out here by itself being added to the entire problem. So the k is a vertical shift. That means we're going to shift it up or down, okay? And those we just take at face value. There is already a plus sign in the original formula. So if I have plus k, that means I'm going up. If I have k, that means I'm going down. But again, I can determine the vertex of that parabola by looking at the h and the k. So let's look at an example here. So I want to identify the vertex. So the vertex is going to be the h value and the k value, okay? And that minus in front of that, or both of them, is important. So this h value originally is a negative, and the k value is also originally a negative. So when we talk about the vertex, my vertex, the one that we take the opposite of, is the h value. So instead of it being -1, it's actually going to be a +1. And then if I have a -3 for the k, that's going to be a -3 for the y value. Now, when I look at the original, so if I were to graph what I call the parent function of a parabola. All right, so if we look at the parent function, so remember, a parent function for a quadratic is y equals x squared. So just nothing being added or subtracted. So we start with the vertex being at 0, 0, and then if we square 1, we get 1, 1. If we square -1, we also get 1. And then if we square 2, we get 4, and if we square -2, we get 4. So this is my parent function here. And y'all forgive me, I'm not the best at drawing these. And then there's my parent. Ooh. Now I want you to look at what happened here. So from 0, we went to the right by 1 unit, and then we went down by 3. So the transformations are the h and the k. So the h value, that means that we're going to go to the right, because it's the opposite, right 1 unit. And then the k value means that we're going to be going to we're going to go down 1 unit. or excuse me, 3 units. Value. So remember, the A value is the number in front. Well, for this one, I don't see an A value right here. So we don't multiply by 0 because 0 times anything is going to turn to 0. So this is automatically going to become a 1. So the rules were that if it's greater than 1 or less than 1, well, it's equal to 1, so we don't have a vertical stretch or vertical compression, and it's not negative. So we have no more transformations that are going to apply to that. All right. So when I look at my parent function, we said that we have a vertex at 1, negative 3. So that vertex, it was originally at 0, 0, so we're going to go to positive 1, negative 3, and there's my new vertex. So again, if you notice, we said we were going to go to the right 1, down 3. So we're going right 1, down 3. That puts me at my new vertex. And I can repeat that for each one. I could go right 1, down 3. And that's going to put my point at that different location. Go right 1, whoop, right 1, down 3. And so that's going to happen on both sides, because it's always going to be symmetrical. So if I were to actually graph all of these together, I should also be able to see again that there is no stretch. There's going to be no vertical stretch. There's going to be no vertical compression because I have an A value of 1. Okay, so that A value of 1 doesn't change whether it's going to get thinner, narrower, or wider. So we just shifted it, and we shifted it to the right by 1 and went down 3 units. So if I look at this, it should have the same shape. Okay, so transformations, shifts do not change the shape of the graph. The only time it changes the shape of the graph is if I have a compression or a stretch. So as best we can doing it by hand, you should be able to see that it has a similar shape, or should be identical shape, and all we did was go right 1, down 3. All right, so if I look at this next one, again, we're going to focus in on our H and K. So here's my H, here's my K. So you can see this is my parent function again. We're going to look at that parent function in just a second, but we're going to figure out that our vertex is going to have an H and K value. Now, the H value right here is a minus negative 2 or minus 2, so we do the opposite of that. That's going to become positive 2. My K is at negative 4, so that's going to stay at negative 4. And then my A value is a 1, so that means that it's not going to make it look narrower or skinnier. And it's also not negative, so it's not going to be a reflection. So at this point, what's going to happen is we're simply going to be shifting this graph, our parent function. We're going to be shifting the graph, and we're going to shift it to, for the H value, we're going to be shifting it to the right. And we're going to shift it to the right 2 units. And then for the K value, it's a negative number, so we're going to be going down 4 units. So again, if I look at my vertex and I plot positive 2 and negative 4, we should be able to see that from this vertex we went right 2, down 4. All right, so if I do that for the rest of them and I go right 2 and then down 4, it's going to have the same shape. It's just going to be shifted. All right, so if I connect those all together, again, as best we can with drawing it by hand, we should be able to see that it did in fact shift, and it shifted to the right and then down. We can also look at this in Desmos, so I have my original parent function. We have x squared. So there's my original. And then we had y equals x minus 2 squared minus 4. And we can see the exact same thing here. So we write 0, 0. And I always like to change my setting and change my steps to be a 1 and a 1 so we can see each unit and then turn off the minors. It's up to you how you want to do it. But you should be able to see that if you see the 0, 0, and this one is at 2, that you can see that that shifted right 2, down 4. All right, so for this next one, we do have a value that's in the front, but we also have to identify the entire vertex. So when we look at our vertex, we've also got to think about the fact that what is my h again and what is my k? So my h, but I don't have a k value. Well, technically I do. If I don't have a k value listed, then my k value is automatically going to be 0, just like if I don't have an h value missing. Or I don't have an h value in the problem and it's missing. So my h value here is going to be the opposite, so it's going to be positive 2. And then my k value is going to be 0. So my vertex is going to be at 2, 0. Now, the other thing that we've got to look at is what happens when we have this 2 being multiplied in front. It's not in the parentheses, it's being multiplied in the front. Well, that 2, so remember we said the absolute value of 2, that's technically still going to be greater than 1. So we have a vertical stretch, and that vertical stretch is going to be a vertical stretch by 2. So that's actually going to make the graph look a little bit narrower. Okay, so that's going to make the graph look a little bit narrower there. So when I look at this problem, the question is how am I going to graph that? We should be able to see it in Desmos pretty easily, but how do we graph that? Okay, so all right, so now that we've kind of talked about the vertex, we know the vertex is at 2, 0, and we know that we're going to have a vertical stretch by 2, which is going to make it look like a narrower graph, and that means that the h value, because it's the opposite, so technically the minus 2 means right 2, we have a process to graph this. So we're going to kind of do it in a couple of steps. So we're going to always start with the a value. So we're going to start with the original, and we're going to start by multiplying the y by the a value. So it is a vertical stretch, okay? So vertically, we are going to be doing something. So vertical means the y value. So if I look at these original points that I have of my graph, okay, I'm going to multiply each of those, and I'm going to multiply each of the y values by 2. So I'm going to kind of show you on the side here so you can see what I'm talking about. So I'm going to list each point. So I have -2 and 4. Then I have -1 and 1. Obviously I have 0, 0. And then I have 1, 1, and 2, 4. So if it's anything dealing with a, that's going to affect the y value, okay? So I'm going to multiply that y value by whatever the a is. So my a value is a 2. So I'm going to multiply this by 2, this by 2, this by 2, and it's going to give me a new point. So if I multiply that 4 by 2, that's going to become -2 and 8. Well, I could graph -2, 8, but it's going to be obviously outside of the graph paper that I have up here. So then I'm going to do 1 times 2, that's going to be -1 and 2. 0 times 2 is still going to be 0, 0. 1 times 2 is going to be 1, 2. And then 2 times 4, that's going to be 2 times 4, which is 8. Okay? So if I regraph these 3 middle ones, so 0, 0 is still going to be the same. Then I have 1 and 2. And then I have -1 and 2. So what you're going to notice is it is actually making the graph look skinnier. It's vertically compressing it, or excuse me, vertically stretching it, but it makes it look narrower than what it was to begin with. Okay, so you're always going to do the A first. Then after you do the A value, then you're going to apply your left and right with the vertex. So because we're looking at this problem 2, 0, that means that we're going to go to the right 2 units. We're not going to go up or down, we're just going to go to the right 2. So from here, I'm going to go to the right 2, and there's my new point. From this new point in green, I'm going to go to the right 2, and there's my new point. And then from this one, I'm going to go right 2, and it actually puts me back on top of this one. So if I put that all together, there is my final graph in purple. So order-wise, you have to do the A value first, and then after you do the A value, then you can do the transformations with the vertex. Okay, and I can always look at that in Desmos. So if I look at my original problem, there's my basic y equals x squared, and then I have y equals, and then I have 2 parentheses x minus 2 squared. So if I look at this, I can see if I have just the 2x squared, I can see that that's where I made it skinnier. So I think I had that one in green. So in green, I went and I multiplied the original y values by 2. Then I shifted it with the vertex, and that shifted to the right 2 units. So I can always check those if I want to in Desmos. All right, so for this one, I have an A value of 1/2. Okay, I do not have an H value this time. That H value inside the parentheses, there's nothing being added or subtracted, so my H value is 0. And then I have a K value of -4. Okay, so my vertex here is going to have an H value of 0 and a K value of -4. Okay, but in order to do this properly and to get the right graph, we're going to start by doing the 1/2. We're going to multiply by 1/2. So in this particular situation, my transformations, my absolute value of 1/2 is less than 1 but greater than 0. So it's going to be a vertical compression this time. Now, if it's a vertical compression, that means the graph is going to look wider. So just like before, I have my vertex and I have the points here. This time I'm going to multiply the y values by 1/2, and I'm going to do the A value first. So if you remember, this was -2 and 4. This was -1, 1, 0, 0. Then I have 1, 1, and 2, 4. So we're going to multiply the y values by 1/2. Now, with that being said, remember multiplying by 1/2 is the same thing as dividing by 2. So this is going to turn into -2 and 2. If I do 1 divided by 2, or 1 times 1/2, that's going to be 0.5. Then 0 is just going to be 0. Then we got 1 and 0.5, and then 2 and 2. Now, you can absolutely estimate a 1/2 point here. So if I estimate my 1/2 point, so at -1, I'd be around here, so 0.5. Then at +1, we'd have 0.5. And then at 2, I would have 2. And then at, or -2, I'd have 2. And then at +2, I'd have 2. So if I connected all of these, I'm going to kind of shift these over just a second. You can absolutely see that this is going to be wider looking because it's being vertically compressed. Vertically compressed means it's going to look wider. Okay, now that we've done that, we're going to end this by actually doing the transformations with the vertex. So we didn't have a left or right, but we're going to go down 4. So from every point, so from this point, that we just graphed in green, I'm going to go down 1, 2, 3, 4. So there's my new point. All right, I'm going to go down 4 again. So this is at 0.5. So if I go down 4, that's going to put me at 4, or negative 4.5. If I go down from there, that's going to put me, whoops, sorry, not negative 4.5, it's going to be negative 3.5. So same thing here. And then finally, if I go down 4, that's 1, 2, 3, 4. So my final graph here is in purple. So it's still wider. It's just that we shifted it down after we did the vertical compression. All right, so I guess I need to write final graph in purple. Same thing here, final graph is the purple. Okay, so if I go back up here, so this one, I do not have a K value this time. I do have an A value of -1. I have an H value that's technically -3. So I know that my vertex here has got an H value of -3 and a K value of 0. So essentially what that means is with the H, that means we're going to wind up going left 3 because it's the opposite. So +3 turns into -3, which means we're going to go to the left and we're not going to go up or down. But just like before, we're going to apply that negative. Now that negative, that means that negative A value means it's a reflection over the x-axis. We do that first always, okay? So just like before, we had -2 and 4, -1 and 1, 0, 0, 1, 1, and +2 and 4. So we're going to multiply the y values, and we're going to multiply the y values by a negative, and that's going to make it reflect over the x-axis initially. So if we multiply, that's going to be -2, -4 now. That's going to be -1, -1, 0, 0. We have 1, -1, and then we're going to have 2, -4. All right, so every y value we multiply by the negative. So if I regraph those, so we're still at 0, 0 here, but at -2, we're now going to be at -4. At -1, we're going to be at -1, +1, -1, and +2, -4. So what you can see is that it simply did a reflection over that y-axis. You can see that this one reflected and reflected down. So we start with regardless of what the A value is, if it's a negative or any number I need to multiply, we multiply that Y value of each original point by the A value. Now what we're going to do is we're going to shift it, and we're going to go with the green one. We're now going to go left 1. So from here, we're going to, or excuse me, left 3. So we're going to go to the left 3 units, and we're going to plot that new one. All right, so again, left 3, we're going to plot that new point. And every one of these, we're going to go to the left 3. And my final graph, after I applied the new transformations with the vertex, is in purple. So we apply the A value first, and then after we do the A value, then you do the reflections from the vertex. All right, so again, we can now see from here, we did a reflection over the x-axis, and then after we did that, we moved it to the left 3. Now, we got a lot going on with this one. So we do have an A value. That A value is actually going to cause some dilation and a reflection. We have an H value that's going to cause us to go left or right. And we have a K value that's going to cause us to go up or down. So if I look at my vertex is going to have that opposite 1 to make it positive. And the K value is also 1. So what are those transformations? Well, those transformations for left and right mean that that -1 is the opposite. So we're going to go right 1 unit. And my K value is up because it's positive, so we're going to go up 1 unit. But we do not do that until after we apply the -2. Now, this -2, so technically, if I take the absolute value, that's 2. So that means that we're going to have a vertical stretch by 2. So it's going to stretch vertically, which means it's going to look narrower. But initially, the A value was a negative, so it's going to have to do a reflection over the x-axis. So this time, we're going to apply, and my initial points are -2 and 4. We got -1 and 1. We got 0, 0. We got 1, 1. And we got +2 and 4. So we are still going to be multiplying. We're going to apply the A value first. We're going to multiply all of the Y's. And we're going to go ahead and do the whole thing. We're going to multiply the whole Y by -2. So if I multiply 4 times -2, that's going to be -2, -8. Well, that's obviously not going to fit on my graph, so we'll leave that one out. Now we're going to multiply each Y. So we're going to do the 1 now. So 1 times -2 is going to give me -2. Then we have 0 times -2, so that's going to be 0 still. 1 times -2 is going to be -2. And then 4 times -2 is going to be -8. So what we're going to be focusing on is these 3 points because they actually fit on the graph. So if I plot those and I go to -1, -2, 0, 0 stays the same, and then 1, -2, okay, I should see that it not only got narrower, but it also did a reflection over the x-axis. So you can see that it definitely is skinnier. So we have this one here, and then this one's skinnier. But then it did a reflection and flipped over that x-axis. Now that I've done that, so from the green, now we're going to go right 1, up 1. So from the green points, right 1, up 1. There's my point. So this one, right 1, up 1. There's my point. So from this one, we're going to go right 1, up 1. There's my point. So my final graph is going to be in purple, just like it has been previously. And it's still skinny, okay? The only difference is that we shifted it, or we translated it after applying that -2. And we shifted it, so my vertex is still located at 1, 1. It's just now skinnier, and it's opening downward because it did a reflection. So, got to remember, the most important piece is that you have to do you have to do the A value first and multiply the Y's by the A value first, then apply the transformations from the vertex. All right, so for this last one, again, we absolutely have an A value of a -1. There is nothing else, so the negative A value means that it's just going to be a reflection over the X. So let's do that first. So that's always our go-to. We're going to do that first. So we have this one. So we're essentially multiplying it by -1. So if I reflect each one of these, so we have what, -2, 4. That's going to become -2 multiplied by -1. So that's going to be -2, -4. So there's the first point. Then we have -1, 1. We multiply that 1 by -1. So that's going to be -1, -1. Then 0, 0. That's going to stay the same. Then we have +1, 1. So we multiply that, and that's going to become +1, -1. So the last one is at 2, 4. And multiply that 4 by -1, because again, we multiply just the Y values. That's going to become 2 and -4. All right, so we have our original graph. We reflected that, and we can clearly see that reflection over the x-axis. It does not look narrower or fatter or wider because we didn't have a actual number that was being multiplied. We just had the negative. Now we're going to apply the vertex. So remember, our vertex is our h and k. So h is positive 1, so it's actually going to wind up being negative. And my k is positive 2. So this is going to be negative 1 and positive 2. So if we have our shifts here, so remember this is left to right, but because we make it into the opposite, that means we're going to go left 1. This is plus 2, that's up or down, that means up 2. So from every point from the green, we're going to go left 1, up 2. There's my new point. Same thing, we're going to go left 1, up 2. New point. Left 1, up 2. Left 1, up 2. Left 1, up 2. So my final graph in purple here and there's my reflection over the x-axis, but then after the reflection over the x-axis, that's when it does the shift because of the vertex, and it goes left 1, up 2. And I can see that the vertex here, that vertex is still at negative 1 and 2. And because my a value is negative, it's sloping downward, which means it has a maximum. And again, just like before, anytime you want to check these out, you can always check them out. So we have negative x plus 1 squared plus 2. So we can see, so like, I'm going to add, so I'm going to just do the negative. So we applied the negative x squared first. Okay, so I'm going to turn that one off, the blue off. So we did the reflection, and then after we did the reflection, that's when we shifted it left 1, up 3. So, important things to remember, absolutely, is vertex, the h and the k. The h is always the opposite. When you have these reflections, okay, when you have the 2's or whatever, you need to graph those first, apply that. Again, you're not going to be doing a whole lot of graphing by hand. The main thing is being able to identify the fact that this is a vertical stretch by 2, which means it's going to look skinnier. This a value was less than 1, so that's going to be a vertical compression. And then being able to tell me the transformation from the h and the k. Okay, but if you are graphing by hand, you start with the a, multiply the y's by the a, then you apply the transformations of the vertex.